So the last question in your assignment book, question 10, giraffe. There are 9 subspecies of giraffe, and what's a subspecies? It's sort of on the way to being a species. They could possibly interbreed, but probably don't at the moment. These subspecies evolved when populations of giraffe were separated for long time periods, and each has a distinct coloured skin marking. So giraffes all look a bit different. And some biologists have suggested up to 6 of these are possibly now different species. Okay. And then how did they evolve from a common ancestor? Use information from the passage. Use information from the passage. Let's do that. So it's our natural selection and evolution theory, just giving examples, particularly with these, the bit of information it gives us, these distinct coloured skin markings. So we start off with this reproductive isolation as a basis for anything turning into new species. So reproductive isolation. You could say there's something like, no interbreeding if you were describing that. You could possibly talk about geographical isolation as an example. So, for example, geographical isolation, which would mean no interbreeding. And then let's talk about how these distinct coloured skin markings could have happened. So, how could anything be different or change? Well, it's always the same answer. It's always mutation. So mutations lead to different skin colours or those markings. And then presumably some colours would lead to better reproductive success than others, and so we'd pass on those alleles for those skin markings to the next generation. So some adaptations, so these markings better adapted, so that's your reproductive success. So I'll put the full word there. So differential reproductive success. So some better example, better adapted, fitter, and then that they will pass on their favourable alleles to the next generation, and that will eventually increase the allele frequency for those markings. So this will change the allele frequencies. Better adapted have an increase in frequency. So that's where those 5 marks are allocated. You might put more information about natural selection in there, but that's what they're wanting on that occasion. Part B. Biologists compared the mitochondrial DNA of the different subspecies and used this DNA to conclude that 6 are separate species. How did they come to that conclusion? We're not asking for anything really technical about the DNA, just that if they're looking at DNA, what are they always looking for? And so, do you remember what DNA is, what it's made up from, and so on? So they're always looking at these base sequences in DNA. So they look at base sequences. They might do things like DNA hybridization that you might know a little bit more about, even though it's not described in detail in the spec. And then for the second mark, what would they be looking for in these base sequences? They'd be looking for, in this situation now, if they're separate species, that the base sequences will be quite different. So the base sequences would be different in 6 subspecies. And on the other side of that coin, you could say that for the 3 that were not, the other 3 of the 9, they're not, so 3 would have more similar base sequences. But you don't need to say that if you said the first one.